Let's look at work done by varying forces. Now, the method we use here to solve work done by varying forces is called the mid-ordinate rule. It's called mid-ordinate rule. This method is known as approximation method. It can be used to solve for work done by varying forces, because sometimes we are given different forces with different distances, or we are given different forces with their corresponding distances, and we will be asked to find the work done. In that case, what we do is that we draw a force distance graph. Then from there we can solve it using what? The mid-ordinate rule. The formula is given as formula is this. It is the work done equal to the width of interval times the sum of mid-ordinates times the sum of mid-ordinates. I will explain to us what I mean by width of intervals and the sum of mid-ordinates. Now, what you are seeing here on your right is a graph, a sketch of a graph. Okay, now this graph has been plotted and it was split into 5 equal parts. As you can see here, 1, we have 2, we have 3, 4, 5, 6. So the first step we take in solving a question in this form is to, step 1 is to draw the graph. Step 1, we draw the graph. All right, that's our first step. We draw the graph. Step 2, we split or we divide the x-axis into any equal parts or intervals. Okay, so step 2 is that we divide this x-axis right here into equal intervals. In this case, is 1, 2, 3, 4, 5, 6. So you are free to divide your x-axis into any number of equal parts. And please note that the more the number of equal parts, the more accurate your answer will be. So we are advised to always divide our x-axis at least to more than 5, at least 5 or more equal parts. That's the first step. So step 3 is that we draw a midpoint, or it's called, we draw a mid-ordinate from the center of each part or interval to the curve. That's our step 3. So as you can see right here, from the center of each of the equal parts or intervals, we draw a straight line from the center to the curve, straight line to the curve, from the center 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 to the curve. Step 3, you draw a mid-ordinate from each of the equal intervals, from the center to the curve. This straight line you draw are called the mid-ordinate. So y1, y2, y3, y4, y5, y6 are called mid-ordinates. Then step 3, you calculate the values of the mid-ordinate to the corresponding y values on the y-axis. So to get the value of your mid-ordinates, what you do now is that you take your ruler and your pencil, you draw from the curve to the y-axis. Whatever you get here is your y1. From y2, from the curve to the y-axis, whatever you get here is your y2. For y3, from the curve to the y-axis, whatever you get here is your y3. The same thing for your y4 to your y6. All right, so therefore I can say that the work done is equal to the width of interval, which is my d, times the sum of mid-ordinates. In this case, is y1 plus y2 plus y3 plus y4 plus y5 plus y6. So that is the formula we can use in this case. Sometimes we might have up to 5 mid-ordinates. You can have 10, it's your choice. But what I'm saying is that at the end of the day, we all will arrive at approximately the same value. So here is how we can use mid-ordinate rule to solve work done by varying force. We are given a question right here. It says the force on a cutting tool of a shaping machine varies over the length of cut as follows. As you can see right here, we have different forces and their corresponding distances. All right. Question: determine the work done as the tool moves through a distance of 100 millimeters. Through a distance of 100 millimeters. Now, the first step is to draw your force distance graph. That's the first thing we do here. We draw the force distance graph. Right, here's my graph. As always, I will label my graph. Here's my force, and it's in kN, kilonewton. Okay, right here is my distance. They are in meters, millimeters. So right here is my distance in millimeters. Let me use a scale of 2 cm. Let me use 2 cm to 10 units. You are free to choose any scale of your choice. Doesn't matter. All right, here's my 0. So 2 cm means that from 0, 1, 2, here's my 10. 1, 2, my 20. 1, 2, my 30. 1, 2, my 40. 1, 2, my 50. 1, 2, is my 60, 1, 2, my 70, 1, 2 is 80, 1, 2 is 90, and 1, 2 is 100. Here's my 100. 100. All right. For my y-axis, which is my force, I can use a scale of 2 cm to 10 units. Okay, I use 2 cm to 10 units. Please, if your graph is too small to get in your values, you can change your scale, or you can use your graph in landscape mode, like what I'm doing right here. So 0, 1, 2 is 10, 2 cm, 1, 2 is 20, 1, 2 is 30, 1, 2 is 40, 1, 2 is 50, 1, 2 is 60, and 1, 2 is 70. Because my highest value for my force is 72. So what next is to plot the graph. Time to plot the graph. So when my force was 60, I have 0 millimeters. So from 0 to 60, I will mark this point. I will mark this point. Very important. When I have 20 millimeters, my force was 72. So 70 here, 70, 71, 72. I mark my point. When I have 40 millimeters, I have a force of what? 65. So 40, this is 60, 65. I mark my point. When I have 60 millimeters, force was 53. 50, 1, 2, 3. 53. When I have 80 millimeters, my force was 44. 40, 41, 2, 3, 44. Okay, when I have 100 millimeters, force was 50 newtons. So I mark my point right here. The next step is to connect the points using a curve. It must be a freehand curve. All right, so I will connect my curve from the point 60. Connect my curve. All right, so here is my curve. So what next? I will divide my x-axis into equal parts. I will divide from 0 to 20. Okay. I will divide from 20 to 40. I will divide from 40 to 60. from 60 to 80, from 80 to 100. So as you can see right here, I have split my x-axis into 5 equal parts. Here's 1, 2, 3, 4, 5. All right. So step 2 now is to find the mid-ordinate of each of my shapes. My midpoint is at this point. So I draw my midpoint to my curve, midpoint to my curve, all right, that's my midpoint to my curve. So I will draw my mid-ordinate at each of the intervals. At this point, here's my mid-ordinate, draw it to my curve, good. I will draw from my mid-ordinate the center point to my curve. Wow, this is interesting. Come again, take it out to the curve. And also from this point to my curve. Please ensure that you are using your ruler. For accuracy, you must use your rulers. Okay. So I can now label my work. Here's my y1, my first mid-ordinate. Here's my y2, my second mid-ordinate. Here's my y3, my third mid-ordinate. Here's my y4, my fourth mid-ordinate, and here's my fifth mid-ordinate. So therefore, it means that my work done, look at this, my work done will be equal to my width of interval D times the sum of mid-ordinates. Which can be written as, in my case, is D times, I have y1, y2, y3, y4, and y5. So mine will be y1 plus y2 plus y3 plus y4 and plus y5. So if you add 10 mid-ordinates, you will have plus 5, plus 6, plus 7, plus 8, plus 9, and plus 10. Now, let's get our width of interval. Now, in this case, my width of interval is 20 because 0 to 20 is the length of each interval. So my width of interval in this case is 20. So I can write my D is 20. If you don't mind, we convert 20 millimeters to meters. That gives us 0.02. Okay? Because our distance was given in millimeters. So I have to convert my 20 millimeters to meters, and I got 0.02 meters. The next step now is to get the values for your y1 and to y5. For my graph, my y1 is right here. I would measure it to my y-axis. As you can see, my y1 is 65, 6, 7, 8, 9. My y1 is 68. So is 68 plus my y2, come to my graph again. My y2 is at this point. My y2, take it down to the y-axis. My y2 is 70. So y2 is 70 plus my y3, come back to my formula, or sorry, come back to my graph. My y3 is right here. Take it down to my graph, as you can see, right here in my graph. Please use your ruler. My y3 is 60. My y3 is 60 plus my y4. Yes, my y4 is at this point on the graph. Take it down to the y-axis. Use your ruler when doing this to avoid any mistake. My y3 is, this is 40, 45, 6, 7, 8. My y4 is 48. 48 plus my y5. My y5 is right here. Right here. Take it down. My y5 that is 47. My y5 is 47. So therefore, my 0.02 times the sum of all these will give us 293. Now 293 times 0.02 will give us 5.86 kilojoules. 5.86 kilojoules. So here is the work done as the tool moves through a distance of 100 meters. It is 5.86 kilojoules.